on iMachining, 3D iMachining for prismatic parts, and to actually show how quickly we can do our operations using iMachining 3D. And I'll show it to you actually in two ways, both using iMachining 2D and using iMachining 3D, and we'll see the advantages of one over the other. Now, before I continue, I'd just like to remind everyone that this webinar, one, is being recorded, and two, if you have any questions at the end of the webinar, all you have to do is click on where it says raise your hand, open up the question box, write down the question, and when you finish writing down the question, click on the send button as shown over here, and then at the end of the webinar, I'll go through all the questions and try to answer them to the best of my ability. Okay. Now, as I said, the webinar that we'll be doing today is on iMachining prismatic parts. Now, prismatic parts, what do I mean by prismatic parts? Parts, for example, like electronic housings and stuff like that, or plain boxes or whatever, or a part that like you see on our screen over here. Now, the part that you see on the screen over here is a very actually simple part. Now, we're actually doing a demonstration on two different parts, this one and another one right after it. And what I'm going to do is first I'm going to put a 3D, iMachining 3D path on it, and then I'll go back and start doing it in iMachining 2D, and we'll see the difference as far as time goes, as far as programming the part itself, and why we actually prefer, in certain cases, to actually do iMachining 3D on prismatic parts rather than the traditional iMachining 2D. In both cases, you should know, however, you'll always get the iMachining efficient toolpath that you need. But, well, let me stop explaining these things and actually start showing you what I'm talking about. The part that we see on your screen, what's special about it is the fact that we have different pocketed areas as shown over here, and areas over here as well, but the height, the depth of each of one of these pockets is different. This and this is one height. This is a different depth over here. This is a completely different depth. This one is a different one as well. And also we have a depth that goes all the way down to this step over here as well as this one over here. So we have different operations that we have to do if we were doing this with iMachining 2D. So let me start by doing some iMachining 2D paths on it. And we'll go into iMachining, choose the option of 2D iMachining, and we'll start actually programming the part itself. Now, the first thing I'd like to do in this particular part, if I'm doing it with iMachining 2D, is actually do this area over here, but I'm going to go down only up until this step. So I'll create my geometry, and in this particular case, I'll create my geometry going from this curve over here, and I'll do an automatic constant Z up until this curve over there. And then I'll just close it up by doing point to point up until this point over there. I'll do the same thing on the other side, start from over here, and do auto to constant Z up until this edge over here, and then close it up again by point to point up until that point. Now, obviously, these areas have to be marked as open. So my first chain, as shown over here, I'll just right-click, mark open edges, and I'll use the option of from to. I'll do from this point, going in the direction of my chain, and up until that point over there. And the same thing with my second chain. I'll choose chain 2. I'll do mark open edges, again using the option of from to entities, and again I'll go from this point up until that point over there, and we're set. Now my depth, my upper plane is over here, and my lower and my depth itself is up until this surface over here. And now we've done our geometry for our first operation. Next, of course, I have to choose a tool. And in this particular case, I'll just use a 12mm end mill that I have over here. And if my level is already set, Technology Wizard, I'll be working level 6. And let's just do save and calculate. Now, we'll run a simulation in a moment. And as you can see the actual toolpath as shown on the part over here. Let's take a top view of it. You can see the actual iMachining toolpath going across the top. And that's actually done very efficient. That actually looks very good. But now we have to do another operation to continue on down. We have to do another operation, say this area over here. Same thing on this side and on that side. So what I'll do is I'll do save and copy. And I'm trying to work as fast as I possibly can. Choose a new geometry. This time I'll use the option of Multichain. Click on this surface over here and on this surface over here. Accept that. And my first chain, I'll mark my open edge over here. That's my open edge over there. And my second chain, I'll do the same thing. Mark open edges, this one over here. Now you see it's actually, I'm getting what I need to get. Now I have to remember, however, that my depth is different. My upper level now is from this surface over here, and my depth itself is up until that surface over there. Okay, I'll just click on OK. Everything else stays the same. And again, just do save and calculate. And now I just want to do now another operation. Now you see the pattern that's actually forming. I have to do each one individually because they're actually different levels over here. So I'm going to do my next one as well. Excuse me. I'll create a new geometry simply by doing multi-chain again. And I'll just touch on this surface over here as well as this surface over there. Those are my geometries. My depth this time, again, don't forget, I have to redo my depth up until that surface over there now. Upper level stays the same. Save and calculate. Now you see, as I'm going along, I will be getting the exact same toolpath that I need, but again, I have to do each one individually because now I want to do this area over here. So in this area, what I first want to do is the top area over here. So again, create a new geometry from, say, from this edge over here. We'll go auto 2, constant Z up until this edge over there. And we'll do point to point up until this point over there. Again, marking my open edge. I'll do mark open edges from this point over here up until this point over there, and that's our open edge over there. Again, we mustn't forget our upper level and our depth being, in this particular case, up until that surface. And again, as I mentioned before, you notice the pattern that I've actually formed is I'm getting my toolpath that I need and getting everything I need. However, it's just taking me quite a while to do this because I have to do each one individually. As far as the toolpath that I'm getting, I'm still getting the efficient iMachining toolpath. Nothing wrong with that. But again, it's taking me quite a while to do this. Again, doing my next area, I want to do a new geometry. This time I want to do this surface over there, so I'll go to multi-chain again. Just click on the surface, accept it, and mark open edges. In this particular case, I'll just mark the edge over here. My upper level in this particular case is this surface over here. and my lower surface, my depth, will be up until that surface over there. I accept my geometry. Again, save and calculate. And one more time, just for this surface over here, we'll do again, save and copy. Create a new geometry again. Again, I like using the option of multi-chain and just clicking on this surface over here. And then just mark my open edges by clicking on this edge over there and this edge over there, those two curves over there. My depth this time, however, is up until that surface over there. Now, I'll click on OK, save and calculate. Now, let's run my simulation on my entire part, and you'll see, and I'll do it actually in Solid Verify, we'll get exactly what we need on the, as far as the toolpath goes. We'll get that efficient iMachining toolpath, but note how long it actually took me. Now, I know the part already, so it takes me pretty quickly actually doing it as far as myself, but even so, it still took me all of these operations to do it. Now, what I'm going to do now is actually do the exact same thing, but let me actually suppress these operations that I've done over here. And this time, however, I'll use iMachining 3D to do it. iMachining 3D. We have our geometry automatically put in over here. Our tools will be the exact same tool I used last time. And I'm just going to go into my levels. My level in this particular case will be only up until that surface over there. I don't need anything deeper than that. All I'm going to do now, you can see our technology wizard also set at 6. Save and calculate. And basically, that's it. One operation. Everything I did before in these 6 operations, say 1, 2, 3, 4, 5, 6, was done now in one operation. Very easily done. I'll get the same efficient toolpath as I did in previous. However, there's less room for error over here, because over here I don't have to pick the depths. It actually takes the depths off the model itself. So I don't need to go and pick each geometry. I don't have to pick each depth. If we take a look at the simulation itself, again, you'll see we'll get the exact same toolpath we got last time, but this time I did not have to pick out the depths for each one of those areas. It was done automatically for me by reading it off the actual target itself. Milling out each pocket exactly the way it should be done. Again, using the iMachining toolpath to do it. However, as you note, again, I did not have to do any kind of picking up the depths as far as the pockets themselves. Yes, I did pick the depth over here because I already knew that I really don't have to go all the way down over there, and it's not going to go down over there anyway, so I just clicked it over here to save some calculation time. But in any case, I only did one operation instead of 6 operations, and this was done by using iMachining 3D. Very simple way to work. Now, I'm going to take another part, okay? Now this part is a little more complicated. This is a very simple part. Now, if I were to load a different part, let's say we'll take this part that I have over here. Okay, the part that we see over here, well, what's so special about this part? Well, one, I'm going to use the big tool I used last time, but we have a little bit of a difference over here. One, look at the outside wall over here. Okay, we have our outside wall over here. If I take a look at the side view of it, you'll see it's actually lower than this wall over here. So we have different types, really lots of geometries that we have to create over here. Also, we have these narrow areas over here. We also have in this area many different heights. We have this height is not the same as this height over here. We also have a different height between this area over here as well. We have this pocket down here, this step over here. These areas over here, we also have this surface over here as well as this top surface over here. So there are a lot of different geometries I have to create for this part. Let me first create the actual 3D operation. Now, if we just take a look first at our part itself with the stock, this is actually how my part looks with the stock itself. Okay, showing it over here. Okay, so you can actually see the stock is we have excess stock on the outside as well as on top. Well, for the top, all I did was a regular face mill. I didn't use any iMachining for that. But the rest I have to use iMachining. So let's first do it using iMachining 3D, and then we'll go into 2D iMachining and see how involved I really have to get into the part itself. So again, I'll use the option of iMachining 3D. Again, using my tool. And my tool, that will be a 12mm end mill. And my levels, I'm just going to leave it exactly the way it is. I'm not going to make any changes over here. And I'm just going to do save and calculate. Again, I'm working in level 6. And it's going to do its calculation now on the part itself. Now, obviously, since I'm using a larger tool, it cannot go into areas such as the narrow areas over here, or these corners here as well. Okay, as we take a look at the simulation itself, let's just first run it using looking at the actual tool path itself here. You'll see that it only can go into specific areas as shown from the top over here. But you can see that it has the exact iMachining toolpath, but every single one of these steps was done in one operation. Let me just click it using, run it using Solid Verify, and you can see exactly what's happening. It's doing every single area. And this was done again in one operation. Now, what about the rest of the material that I couldn't get into before? Well, what I'll do is very simple. When I finish the simulation over here, you see it got down to every single area, but certain areas were left out. I'll just do save and copy. And all I'm going to do is change my tool. The tool will be, this time, a 6mm end mill. And I'll just do save and calculate. Now, because when it looks in our geometry area, it looks only in the area, it will machine only areas that were not machined before. It'll only work in the areas where it needs to work. Now, again, you have all of these depths over here, which I did not have to deal with. It was done automatically. The calculation will be finished momentarily. Okay, now remember, it's actually calculating every single one of those levels. So it does take, the calculation does take a little more time, but we're just about finished now. Let me run my simulation. And this time, as you can see, it's only machining in the areas where it needs to machine the part itself. Okay, only in those areas. And what's the beauty of this whole thing is that I did not have to pick any depth. It did this basically in two separate operations. So let me stop this for now, because I'm going to actually get back to this in a moment. Now let me suppress what I've done up until here, and let me actually start doing this using the iMachining 2D. I'll suppress this. Okay, and we'll run our 2D iMachining instead. Now, if I'm looking at this from what I have over here, my stock, the first thing I want to do is mill the outside of the part. So I'll go into my 2D, iMachining 2D. We will create a new geometry. My geometry will be starting from the outside over there, auto constant Z, marking that as completely open chain. Mark chain is open. And my second will be this chain over here, going around the part as shown over there. Now, the tool, again, I'll use that 12 millimeter end mill, not a problem there at all. Levels, I have to remember now to pick my levels. Now pick my levels at the bottom of that part over there. And save and calculate. Okay, that's actually done already. Now, my next operation, actually let's take a look at the simulation over here. This will be a very quick simulation. You'll see it just works on the outside of that part, which is exactly what I wanted. Now, my next operation is I would like to actually do this. Let me do save and copy over here. Go to creating a new geometry. And actually, let me take away the stock and let's just look at the default part itself. What I'd like to do now is actually mill this area over here from this step down here up until here. So my geometry has to be picked around over here up until this point over here, and then going along this closed edge over there. So I'll create it by doing the following. I'll go from this line over here. Let me zoom in so I can really grab it well. And note, I have to create all these geometries. Okay, now this can be time consuming. As you see, that's exactly what it is. And I'll go now, auto 2, constant Z, up until which area? Sorry, I overshot myself over there. Let's do undo. Okay, we just add this one over here as well. And what I want to do now is do point to point up until this point over here. Then I'll do just curve, this curve over here, as well as this curve over here. And then again point to point up until this point over here. Okay, now we've closed the chain. However, I still have to mark open edges. So I'll just go and use from to. From which point? I'm going to go from this area, from this point over here, up until this point over there. So it means basically that this whole outside area can be taken care of from the outside. My depth, though, we cannot forget to take care of that. My depth has to be up until that point over there. We'll accept it, and we just do save and calculate. As we take a look again at our simulation, you'll see that this time it mills exactly where I want to over there. Now I have to go down to my next step. Now my next step will be the following. Let me again create my geometry. Let's take a look at the default part itself. What I'd like to do now is go down from this step over here all the way down to here. Not a problem. We'll create a new geometry, and this time the geometry is going to be this area over here. So what I'm going to do over here in this particular case, we'll do again, choose this edge, this time the inside edge over there, go automatically up until this edge over here, do point to point. So as you see, I'm doing a lot of manipulating to get what I need. Choose a curve, this one, as well as this one over here. Again, point to point. We're going to go down up until that point over there. And then we've created that geometry over there. Now, of course, I have to mark my open edges. So my open edges in this particular case is going to be mark open edges. I'll use the option of from to. Since this is not an edge I can pick, so I have to use from to, from this point up until that point over there, as well as the other side over here, from this point over there up until that point over there. We're all set over there. Don't forget, we still have to take care of our levels. So my upper level in this particular case is this surface over here, and my depth will be up until this surface, up until, let's see, we'll take that point over there. We'll accept it, save and calculate. Now, what I want to do now is go down to my next step. So again, I'll do save and copy. And again, you see the pattern that's forming of having to choose every single one of the geometries over here to do this, and also always making sure that I'm creating the correct, choosing the correct depth at each point. Now, of course, I'm only human to the time, and or the times anyone can make a mistake. But when you're working on 3D, you don't have that mistake because the depth is always taken off the model itself. So let's go down to my next level. I'll just do multi-chain onto that surface over there, and I'll take my very first chain. You notice we have islands over here. My very first chain will be mark open edges. That will be this edge over there, as well as this edge over here, and of course that edge over there, as well as this edge over there. Those are open edges. Okay, we'll accept them. My depth will be this time from this surface going down to that point over there. Save and calculate. Now, as we know, however, these areas still need a smaller tool. So I'm going to do save and copy. I'm going to use a smaller end mill now for the rest machining. Rest. I'll use a smaller end mill. Sorry, use that smaller end mill. My mistake over there. Depths stay the same. And everything is fine over here now. Now, this is finishing. Now I have to deal with the inside over here. Let me again do the default part. I still have to deal now with this area over here. Now this even gets to be a little even more tricky. I still have to do these pockets over here. So again, I'm going to create a new operation of iMachining 2D. Create a geometry. Let's first create one over here for this pocket over here. I'll take this area over here, this edge over there, and do auto constant Z. My upper level will be 0, and my depth in this particular case will be up until this surface over there. Okay, everything's all set. All I need to do now is choose my tool. I'll choose again my 12mm end mill. Save and calculate. Now I want to do the next level. Now the next level is a little trickier even, because the next level, if I were to create a new geometry, is going to be from this surface up until this surface. So my geometry in this particular case again has to be around over there, but this also has to be included. So what I'm going to do over here is, since I want to go down from here to here, these are considered islands over here, I'll do the following. Create this chain over here. Now, you really have to study your part in order to get exactly what you need to do. My next geometry will be this edge over here, creating that island. And the same thing with this one over here, creating the island over there as well. My depth, upper level, will be over here. Pocket depth will be up until that area over there. Save and calculate, sorry. Again, what I'm trying to bring out over here is showing you exactly what's involved when doing more complex part. Now, the toolpath I'm getting is excellent toolpath. No doubt about it. The toolpath itself I'm getting in every single one of these cases is perfect iMachining toolpath. Exactly what we need. However, you know how much work I'm actually doing to get to what I need to do. Again, I want to go down now to my next level. This time I want to do this floor over here. So I'm going to create a new geometry. Now this time when I create my geometry, I'm looking at this floor over here. I have this area over here. So you know what? This time I'm going to create a geometry that goes around these areas over here, but also treats this as a straight floor over there. So what I'm going to do is create a new geometry. And again, I have to always know exactly what I'm doing. I'm actually going to start from this edge over here. I'm going to go auto 2 up until this edge over there. Then what I'll do is I'll do point to point up until that edge over there. I'll choose a curve now. The curve will be this curve over here. Now let's continue on with the auto constant Z using auto 2 option over here up until this arc over there. And then again, I'll go back to point and choose this point over there to close it. Now that's fine, we have no problem over there. I still, however, have to create the islands over here, as I do not want it, I want it to machine on these floors, but not the islands itself. So I have to remember to choose that as well. So I'll choose this edge over here, as well as this one over here. Create that. Don't forget my levels. Now we're going to go down from this surface up until this floor over there. Save that. Do save and calculate. Now, what I still have to do is, since there are areas over there that need a smaller end mill, because we have those corners, I would have to use a smaller end mill. But let's leave that alone for now, and let's work on these areas over here. Now, in this particular case, I'm going to use a geometry that's from this surface, that edge over there, going around, and my upper level will be over here, and my lower level will be, my depth will be up until that surface over there. Again, I'll be using the end mill I used before. Save and calculate. And now I still have that floor to do. So let's go continue on. Now you see how much work I'm actually doing over here. I'm doing a lot of work. I'm sweating a lot. But again, I know the part. I've studied it very well, so I can actually do it pretty quickly, relatively, as over here. If you're getting a new part, it's a lot harder to do. It's even harder to do it when you're getting a new part and you really have to start studying every single aspect of it. I'll go down and create a new geometry. I'll choose the option of multi-chain on this floor over here. In this particular case, I'm going to use immediately, first of all, my upper plane is over here. My depth is up until here. And I'll use already a smaller end mill since I'm only working in these small corners. It doesn't pay to use a bigger end mill over here. So I'll go over here, use my smaller end mill. Everything's fine. Save and calculate. Now let me go out and run my simulation on the entire and everything that I've done over here. Run simulate, and you'll see everything will be done exactly the way I wanted it to be done. Okay, but I had to make sure I picked the right depths for each one of those operations. I had to make sure I picked the correct geometries for those areas to work in. Okay, so everything was based on the fact that I knew exactly what I was getting myself into when I picked each one of those geometries. Okay, as shown over here. And I'm not even finished really with the part. I still have more areas to do. And you see how many operations of that, and you see how long it actually took me to do this. So now, again, just to remind you what I did in the very beginning, I'm going to take all of these operations I did over here, suppress them, do a iMachining 3D instead, iMachining 3D, choose a large tool, 12 millimeters, levels, I'm not going to touch that, leave it exactly the way it is, save and calculate. Now, obviously, the calculation takes a little more time, but note, I'm going to be doing all of these surfaces within 2 operations instead of, and I don't have to worry about picking the proper depths over here because everything is automatically picked off the actual model itself. Run my simulation. You'll see it'll do exactly what it's supposed to. Let me actually speed this up a little. Works in every single area exactly the way it's supposed to. And then all I have to do, save and copy, just change my tool for those smaller areas. I'll change my tool. Now remember, in my geometry we have the working area, which is marked off automatically, cut only the rest material. So it only works on the areas where it needs to work. Again, save and calculate. Let it do its course of calculation. And then we'll basically be done with this part. Now, as far as removing the material over here, let it finish the calculation. In a moment, we'll show you everything that was done over here. And what you actually see here is instead of having all of these operations from this down here, which is not even the entire part, which is still areas that I didn't even touch, such as these holes down over there. I didn't touch this entire pocket down here. I didn't even deal with that at all. Okay? Or I'm dealing, so there are actually more operations that I would need to do this entire part. But now I've done that basically now instead with using the iMachining 3D in 2 separate operations. Run the simulation now on this. And you can see it works just in the areas where it needs to work. Going inside those pockets, these areas here as well, everything is done without me telling it again what depth I need to go down to, where to work. It's doing that automatically on its own using the iMachining 3D option. Okay, now again with the regular iMachining, I get the I've gotten with these operations here, I've gotten the good toolpath as well. I've gotten the iMachining toolpath in any case. But with the ID3 machining, with the iMachining 3D, I actually got this done a lot quicker. Advantages of one over the other. Well, you saw the advantages of using this operation. This is actually very good, especially when you're doing parts that won't repeat themselves. You're doing a prototype. These are excellent for prototypes as well. The advantages of the 2D iMachining over this is that in 2D iMachining you can actually do specific areas sometimes when you want to do a specific area, and you have more control. But then again, you always have to remember that you have the complete control. You can make a mistake sometimes picking the wrong surface or picking the wrong geometry. You have to be careful of that. Using this option over here, you don't have to worry about the geometry, because that there is automatically taken off the part itself, as well as the proper depth. Okay, I'm going to go into questions now. And before I continue, also, let me also mention that upcoming in SolidCAM 2014, we've actually have done a lot more. We'll be doing a lot more with prismatic parts, specifically for prismatic parts, not just any iMachining 3D part, but specifically for prismatic parts. What I mean by that is that it will have also separate offsets for floors and walls. It'll have a lot quicker calculation, a lot more pocket control, something that will be done also again automatically, with a lot more features specifically meant for prismatic parts. The one thing over here, as you notice, it has not done, I cannot do a separate offset for the wall and floor, but in the new one in 2014, you will be able to do a separate offset for walls and floors, and also finish cuts as well. Not only just roughing cuts like I've done over here, but we're talking about finish cuts as well. If you ask me how to do a finish cut on a part like this, I would use the HSM using the prismatic part option, or a combination of linear and constant Z and horizontal floors. But as far as everything else goes, the iMachining goes over here. This is a really nice way to work, especially when you're doing prototype working. Okay, let me go into the questions now. Okay, with iMachining 3, is it possible to finish the floors and pockets but leave? Okay, that I answered that. In 2014, we will have a specific operation for that. Okay, there's 3D iMachining cope with fillet radiuses between wall and floors. Yes, it does, because it still reads it as a 3D part. So when it sees that radius on the floor, it'll make that step it'll make that step on those corners as well. So it does deal with that. It's not a problem at all. What we'll also have in the prismatic part for iMachining in 2014, we'll also have the option of taking care of actually controlling the amount of steps you have on the bottom over there on the floor itself. But you can also do that with the way you have it now, just by making a smaller scallop for your step-ups inside your iMachining 3D, and you'll get your small steps on those radiuses on the floor itself. Okay, any more questions? Okay, one more when will 2004 be out, and will it be for InventorCAM 2? 2014 SolidCAM 2014 should be out by the end of January. That's when it's supposed to be released, and when after that, it will be also available in InventorCAM 2015, which is 2014. InventorCAM has been released. 2015 will be released. It may, I can't say for sure, but it may be also in one of the service packs in InventorCAM 2014 later on, but that I can't guarantee. But it definitely will be in SolidCAM 2014, and that should be released, as I said, at the end of January. It's planned released. Okay, now one more thing I would like to mention is that a couple of weeks ago, in the webinars, we had a problem with the drivers for the NVIDIA card crashing, and I had mentioned to update your drivers. Now, the very newest driver of NVIDIA is actually not the best one that should be used. There's another one instead, which is actually recommended by SolidWorks itself, and that's 2000. The driver is released 3.11.5. But if you go onto SolidWorks site, you'll actually be able to see it there as well. That is the correct one to use. So if you're having problems for your NVIDIA card where it's crashing on your SolidWorks itself, just redo the driver to the one I had just mentioned. Okay. I'd like to thank everyone for joining the webinar. Again, this webinar has been recorded and it will be available on our site. Everyone take care and have a fantastic weekend.